Hello. So today we are going to recap what we have latest in the DevSecOps space. Considering the latest advancements we have in the SaaS applications, all the new cloud options we have from Azure, Amazon, and Google, and also all the advancements that we have from the AI and the generational AI. So we'll see what we have as the industry standard recommendations from bodies like Gartner and OS, and what should be the ideal DevSecOps cycle these days. So starting from OS, what we have is basically this template or a blueprint. It does have almost all of the artifacts. It does not illustrate IAST, which is another small thing, a small variation of dash basically. We'll come to that. So this is one scenario. I mean, it encapsulates some of the technologies also, and then basically it starts from the code commit, where the basically pipeline gets initiated, a branch is getting triggered so that a build is developed. So basically it tells you that you have these number of phases, either for the infrastructure development or for the application development itself, for the whole of the pipeline. So there are a number of technologies involved, and then we have some guidelines from Gartner also. Basically, where Gartner emphasizes on the integrated approach, where the SDLC, it should incorporate DevOps and map all those phases into the DevOps itself. And it is also making very good sense, by the way. And we will see all of them. But let us just quickly finish with what OAS have to say. It's the latest guideline, point 2 from OAS for last year 2024. So basically it starts from where the commit happens, and then you have the secret scanning. If you do not know, secret scanning is basically about not storing the password as a part of the source code or even the pipeline code. It should be handled separately. There is a secret management tools available. We'll get into the discussion which one is ideal, how to develop your own even. It's very easy to develop your secret management tool, by the way, because it's just about hashing and encryption, and we'll see how to get that done. And then there are a number of other options also available. For example, in the most free one, the GitOps also. So in GitHub also, if you notice, there is a secret management options there. You can create secrets there and utilize them directly. So this password thing is itself a very long subject, the password length and all those complexity. There are a number of standards governing that. So instead of getting into that, just let's finish with the pipeline first. So we'll start with the first phase, which is called static application security testing. So it's called static because basically it surrounds around the source code's static analysis. It finds the major bugs, major patterns that are there. It's a very old and legacy thing which is getting carried along, and it is of course the most important one. So you check for nulls and all those things where the obvious catches are not there, and there are a number of technologies that have been there from quite some time, like SonarQube was there. Synopsys is also is there. It's not illustrated in the OS diagram, but it's basically a very good tool. And then there is a concept of software composition analysis. It's not very old, but it's also a very powerful one. Synopsys is also offering, besides these companies, they have one solution, I think Black Duck. The concept behind software composition analysis is it goes to check all those open source component that you're using in your pipeline or in the software, for example, and it will check for the known vulnerabilities there. It's check for the licensing issues there. So it will already be having the database for all the source code components, especially in the front end. If you notice, there are tons of front end sub modules that get basically built along with the application. It's very useful for those things because number of vulnerabilities recently have been detected coming from the dependent packages that are not the subject of the main application. So there the SCA is very helpful. And then there is container scanning because the modern day development, it happens sometimes developers are doing development in the containerized environment. Compared to the legacy environment, we had the developer's laptop, it had everything set up once and then they are developing. Now the modern day, sometimes you are not doing that. You can skip altogether all that. You have a container with all the build environment and all the dependencies already there. but the security of the container is an important thing then. What about, for example, you have something in the container that is even a simple keylogger, that is, copying all the thing that you're typing, or maybe taking the screenshots of everything that is there, or maybe just copying all this source code right from there. So while the facility is there, it saves a lot of time developing the environment for the developer for the development, but definitely the security of the container becomes a very important matter at the same time. So there are a number of tools available, of course, for there. Synopsys also have one offering for this, by the way. So by the time if you notice, there's a pipeline getting executed for the code. Modern day infrastructure also basically is not like a traditional where the one-time infrastructure is deployed for the application. It's also pretty dynamic. These days we have a technology which is called ISE, infrastructure as a code. So basically in a one file you have deploy all the infrastructure, number of servers will be there, number of containers will be there, backend database will be there, all will be basically deployed using that single file or set of files. Either they can be Azure Bicep files or they can be Terraform files. And definitely the infrastructure is also deployed in an automated way through those files, but then security of those things also get carried along. Same for the secret, for example, then for the Terraform there is the Terrascan. There are a number of other technologies also scan those files. There could be vulnerabilities there also. For example, they can exploit the infrastructure, the cloud infrastructure that you would be using to deploy your infrastructure on. So the security starts from there as well. And then when we proceed from there, you have basically a deploy stage and then infrastructure scanning also, which becomes very prevalent. Earlier in the classic era, we had Nessus and all those vulnerability scannings and then the normal scanning that of the vulnerabilities that you used to do in the production environment or in the test environment for the designated VMs that have been deployed. But now this have changed. It have to be dynamic. So as soon as the infrastructure is deployed, as a part of the pipeline, the scanning need to be done. So all those scanners need to be flexible. The newer companies are basically supporting that model. So while you deploy your infrastructure dynamically using a single file, number of servers, number of containers, it need to be scanned right then. And then based on that thing, basically it can go further to the production. You can set the threshold, okay, this and major vulnerabilities that cannot be should be not be in the production, then you can filter that out. And then there is definitely a central vulnerability management for not just this CI/CD, it can be for the rest of the vulnerabilities of the production. So moving forward from there, basically then we come to the deployment stage where we have DAST. Now basically this IAST also, DAST also, and static one also, SAST also. The difference between DAST and SAST and ICE is that DAST is dynamic. It's like you use tools like Selenium, Protector. You basically deploy the application and then you test it like a user. For example, in case of Selenium or Protector, it deploys your application in a headless browser. And then it has scripts and all those unit tests, which basically acts like an end user, but in a automated way. So it simulates all your buttons on the web browser and then it tries to produce all the result sets from there. So it saves a lot of time doing all the manual testing. You have a virtual browser, it's called Chromium by the way, and then you have the testing also done using these stacks of Protector and Selenium. And there are other tools also, not just Protector and Selenium. In fact, Synopsys has a variety of tools also for the DAST besides these some listed here. So DAST is very important. Basically it automates all the normal legacy human testing in a very and a beautiful way. So further that, there is the IAST concept also these days, very new. It's especially coming from Synopsys. Basically that is a mix of both SAST and DAST. So what it does is basically DAST is just a black box testing where it tests your deployed application and tells you that these are the problems. But IAST is even smarter. IAST basically not just that it finds the problem, it has the access to the source code also. So it's a mix of both SAST and DAST, where it goes directly to the line of the source code or the set of functions or the classes, and it can highlight the problem from there. So it's smarter one. It's the latest one. So and companies like Synopsys are providing that solution. This is called the Synopsys Seeker by the way, so that you can use. And although it's not highlighted by OS as IEST, but it's something that should be considered for the modern day security. And then of course when you deploy all of this along with the infrastructure or your application, then definitely continuous scanning is very important, contrary to the past where you scan it once, but this need to happen more often now based on the type of security problems that are going on. Number of ransomware attacks, as you know, are there already. So when we come to the Gartner, the difference is just that they include more basically. They just do not say SAAS dash ISV, they have much more thing because they are bringing on all of the security posture or the security elements that are there normally in the SDLC, and they are trying to map it to the DevSecOps, which is a more comprehensive approach to the security, by the way. If you want a full end-to-end secure thing, I believe Gartner is more comprehensive. But anyway, it can be addressed also. So starting from the threat modeling basically, which you normally do, so you have number of options available that you can use. These are the prominent big players, by the way. Security training, because when we consider the SDLC as security, then definitely secure coding comes in. There are a number of sections from the frameworks of security where basically security starts right from the secure coding section. So security training is also very important part. The developers need to train. There are a number of companies that are doing that. Number of patent products are listed that can help you do that. And then source code protection policies. Of course, you have a branch policies where you commit the source code in a central repository. The security of the repository itself, who can check out the branch, and then who can commit the branch, and then like that. So it's just one-time operation that you do now only when you're setting up your repositories and when you're deciding about the branching strategies. So based on that you can set that. And then trusted component repository, where the sub components are coming from. Normally if you have the normal inbuilt for example repository, for example some people use GitHub, it's more of an open ecosystem. Sometimes enterprises do not want that. For example in KSA and Gulf and other countries where there is the big the core important information we cannot have on the public cloud. This may be something very secured, so you can have your own enterprise GitLab where you have your own server and you're keeping everything there. So both approaches are there, and where you can have your own sub modules or the components that are being used by the application that can be used from there also. And then secret scanning, of course this automatically checks if you by mistake put in the passwords there, and it can check those all the password level vulnerabilities that you left in the code. And then there is a secret management, how you are actually going to store those secrets. It's another basically a comprehensive the dimension where basically a lot of details are there. The password length is there, password rotation is there, how you are hashing the password, are you storing them in the reverse hash or not, and then which hashing algorithm is getting used. So it's a big science. We are going to delve into that. We have, in fact, I have a recommendation on how to develop your secrets management solution also. And this is a SAAS-IV, we already discussed that. There are a number of tools available. Synapses delivers that, and in the earlier diagram I showed you some options there also. Semantic code analysis is also the same thing. It's more of a static thing which have been already been there, and these are some of the options that you can use. So basically semantic is about it's just a level above normal syntax, where basically some functions they are emulated, and you can immediately tell whether this code is going to create a problem for security or not. So it's similar to SAAS but a little different actually. And then API, definitely it's a science of itself. You have a rate limiting on the API basically, then you can number of DOS attacks just possible on the API also. Now these days you have Graph API also, which is a very different thing from the legacy REST API that we had. And then even considering the REST API, there are a number of reverse proxies that are available. This is an NY proxy and the number of other proxies that are available that you need to look into. And then mobile application security is another science completely by itself, because it has number of new dimensions for the mobile platform. Then there is firmware security also, which is basically sometimes not very relevant, but as a part of a pipeline or overall application security, this sometimes becomes relevant. So although every machine that you use, even the mobile phone, they have some sort of firmware. Firmware security also comes in when you are talking about 100% end-to-end security. And then govern the use of, this is software composition, SCA we already talked about in the earlier diagram, how we basically check for the open source vulnerabilities and all those things. And then this is a small concept of software bill of material for security and compliance, whether the license that are even listed in the open source components, whether they comply to your requirements or not. So this helps in some of the areas basically. Code signing, definitely you need to sign the code. If you remember all the .NET DLLs and all the files, the code file you need to produce, even the JavaScript file, they can be code signed also. And how you basically sign them, the length of the key, and then which company you're taking the certificate from. Is it your own public key, I mean the PKI infrastructure, you have your own server that you're going to generate it from, and are they basically having the chain with the top level PKI servers of the world or not. So this is about that. So similarly there is a first testing, and then there is a penetration testing, which happen normally for the all of the infrastructure, like you have network devices, firewalls and everything. But since, as I said, Gartner basically emphasizes mapping all of those technologies to the DevSecOps also. So basically it's highlights that also. So the penetration testing should be done right after the deployment, and then you should be able to know all the, the vulnerabilities that are there from the penetration testing point of view, considering the overall application. And then infrastructure policy as a code. This is not just the infrastructure, it's an infrastructure policy also. Like for example, it covers the network aspect also. So sometimes you have QoS and all those elements there, right? So it incorporates those part also. And then there is application shielding and in-app protection, and then artifact repositories for the release and configuration phases, compliance automation. Sometimes you want to do some compliance check also as a part of this when the compliance is really needed. For example, in some applications, some organizations, then this can be done in some of the tools, and there are a number of tools available for the compliance. It's a complete science actually, the compliance of the software actually. Then there is the posture management, API management and security. And then there is a basically configuration, drift detection, secret leak detection basically. And then you have PAM solution. As you know, PAM basically gives you a very confined access to your development machine. So in this basically, the PAM is basically talking about even the development machines or the container, they should not be accessible without the PAM. Basically the purpose of highlighting this by the Gartner is that basically machine identity management, where the basically the machine that you are using, it should have a unique identity. So it's an entirely new concept also. And there is a new trend of zero trust network access, and then there is a concept of MFA also. This is not the MFA for, by the way, for the application. This is MFA for the access of the development machines or the development platform for the development actually. So here basically Gartner is emphasizing that it should be done for the development machines also, because for example, if some development machine is in the hand of a hacker, they can have access to all of the source code also, and that information can be later in point used by some vulnerability or some hacking tool development. So they are emphasizing basically, and they are rightfully saying that security starts right from the day one. All those development machines should have the MFA also, not just a normal password. And then vulnerability management, we already talked in the first diagram, where you should already be having it in the central place. There are number solution call is also tenable there, so it can be integrated basically. And then there is API protection, we already discussed that. And then web application and API protection, definitely there are a number of WASP rules that we talked about, and they are here discussing number of solutions for that incorporates basically that. So it's basically most about web application firewalls and web firewalls that are available in the cloud platforms also, or on-prem also there are devices available that people use. And then there is a number of security options that are available for the containerized environments. So you have these things that you can use. because this is a relatively new platform, and even the development environment are using containers these days. So the security also is needed, because that's much of an isolated environment where security is equally needed. And then you have these days a new type of thing which is called serverless functions. These were not there in the past. So the basically is more of a serverless computing, where you have your Azure functions or AWS Lambda functions executing somewhere in the cloud. So you need to secure them also, basically. So how you communicate with them, and then how the response is returned. So basically there are a number of solutions for that also. In the later drill down that we are going to do, we'll be discussing another separate video how that is getting